Hi there, guys. So this is 14B. We are doing hypothesis testing here. This idea is going to turn up a lot in a lot of the subsequent exercises. We're basically testing whether or not our data fits an original pattern or it follows a new pattern. And that could be dependent on different distributions. In particular, we're going to look at the normal distribution, the binomial distribution, the Poisson distribution, and then there's some more hypothesis testing later on as well. But we'll kick things off with a question on the binomial distribution. So we're going to test whether or not some data follows a particular binomial distribution or whether it doesn't. Okay, and that's going to be to a certain amount of significance. Okay, so let's look at the question. So we're going to look at example 2, and I'm going to take you through all of the steps of this. It is important that you get these steps sorted out in your mind. So let's read the question to start off with. So what have we got? We've got here, let's just hide up some of this so it looks a little less messy. Okay, so it says a food scientist is trying to determine whether a new version of cheddar cheese is regarded as more tasty than the original type. Okay, in order to do this, he carries out a test with 20 people in which they're given 2 types of cheese without knowing which is the original and which is new. And he asks them to pick the one which they prefer. His null hypothesis is that there is no preference. So each cheese is equally likely to be selected. And his alternative hypothesis, so his other idea, is that in fact the new cheese is preferred. He decides to perform the test with 5% significance, or with a 5% significance level. Okay, so if there's basically no difference between the 2 cheeses, then you'd expect people to choose randomly between the 2 cheeses. They would choose 50% chance one cheese, 50% chance the new cheese. Okay, and in terms of how that will look as a distribution, you will expect out of 20 choices here, out of 20 people, that the most likely option is you're going to have 10 people, in other words, 20 times by a half, that's n times p for a binomial distribution. You're going to have 10 people, which is the most likely scenario here, as saying they don't favor one over the other. Okay, now in fact, what we're talking about here is a binomial distribution. So x is binomially distributed with n is 20, and the probability of choosing one or the other, so success or failure, is 0.5. Okay, and in this case it says let x be the number of people who prefer the new cheese. So this is 0.5 preferring the new cheese. Okay, so this is the null hypothesis. This is the old idea. The alternative hypothesis is that, in fact, the 0.5 is wrong, that the new cheese is tastier, and so the probability of picking that new cheese is going to be bigger than 0.5. This is called a one-tailed test. And later on, we'll talk about two-tailed tests, but this is complicated enough as it is at the moment. So we'll keep to this one-tailed test at the moment. Okay, so this is what the distribution should look like with the null hypothesis, under the null hypothesis. This is what we would expect if there is no difference between the old and the new cheese. Okay, so there we go. Let's just take that back for a moment. Let's make this a little bit smaller, and let's try and answer some of these questions. Let's just put that down there for a moment. Okay, so question 1 says, if P is the proportion of people in the population who would prefer the new cheese, state the null and alternative hypotheses. Well, one thing to note is when they say P is the proportion of people, that's interchangeable with them saying the percentage of people. It's just when we're talking about N and P, they're talking about P here being the probability of picking the new cheese. Okay, so what you'll need to do for all of these tests is you will need to state your hypotheses. So here we go. Here's how you state them. The null hypothesis is given as, let's just get the rubber. So is given as H0. and the probability is 0.5. That's the little graph down at the bottom. And H1 is the alternative hypothesis, and that's where we say that the probability is greater than 0.5. Okay, so that's pretty straightforward, but you will need to do that to start off with. That's where we're starting out. That's our idea. That's what we're trying to test. Okay, so let's just take this back as well. Okay, so then for question 2, find the critical region for this test. Okay, so the critical region is the region where you have 5 or less percent in this graph. Okay, so it would represent 5 or less percent at the top end of the graph. And that's the reason why we talk about the 5% there is because it's a 5% significance level test. If we were looking for a 10% significance level test, that would change the critical region. But the critical region is basically, we're trying to identify the number of people that we would require to prefer the new cheese in order to say, this is significantly different from the original idea of the distribution. So if we're in the top 5% of this distribution, of the original distribution, then we're starting to think that probably the new cheese is preferred. And it's preferred to a 5% significance level. Now, as a statistician, you could make it more likely that you accept the alternative hypothesis if you made a 10% level. So if you were an advertising company, a marketing company, and you were trying to prove something, you could say, well, at a 20% significance level, we accept the alternative hypothesis that this cheese is tastier. Well, that's not saying as much as at a 5% level. Okay. Now, at a 5% level, we still might be getting things wrong. It still might be the case that say, for example, we get 18 people. So within this critical region, the 5% at this end, say 18 people decide, and then later on it says 18 people, in fact. So say, for example, 18 people choose the new cheese. Well, you'd be pretty convinced that the new cheese was better than the old cheese, was tastier than the old cheese. But there still could have been some element of random chance that ended up where we had 18 people choosing at the 5%, 18 people choosing the new cheese over the old cheese just randomly. Okay, so we need to find out, because it's 5% significance, we need to find out at what point are we in this critical region of having only 5% of cases being in this region, 5% of answers coming out as this region, 5% of results coming out in this region compared to the original distribution. Okay, now you can see this in green, by the way. Okay, so there's the 5%. Okay, so they want us to find the critical region for this test. So let's have a little look at what they're saying here. Let's take that down there. So what they're saying here, let's put it up there. So they're saying, let X be the number of people in the sample who prefer the new cheese. Already been told that. Okay, that was up there. So suppose the critical region is X is greater than or equal to R. So what they're saying is there is some value here where we're going to be within this region. So what we want is for that value to be less than or equal to 0.05. We certainly don't want that value to include 6%. So 5% is the best amount of significance that we could potentially have here. It's not going to be 6% significance. This could not be less than or equal to 6%. Okay, so in other words, we need to find this value down here somewhere or other, which gives us less than or equal to 5% when we're looking at a cumulative probability from that value onwards. Now, my suggestion here would be to use some trial and error in this case. So I would say, find out with your X is binomially distributed with 20 and 0.5. I would put in just trial value. So I would say x is greater than or equal to, and then maybe try, I don't know, start off with x is greater than or equal to 12. Okay, and you can see that that will give you too high a percentage according to this. So we're just going to scratchpad on our calculator on the TI Inspire or the equivalent facility on your other calculators. And we're just trying to find out the probability based on the binomial distribution using the binomial CDF. Okay, so you'll find out that x is greater than or equal to 12. So that's from 12 up to 20, which is the maximum number of successes. You'll find out that this is too big. This is greater than 5%. So we're going to need to keep going until we get to a point where we're underneath 5%. So you might try next, x is less than or equal to, or is greater than or equal to 14, and so on. Okay, now let me try that on the calculator actually. So let me see on my calculator. Let's go back to home. Let's go to calculate onto Scratchpad. I'm going to go to menu. I'm going to go to probability, go to distributions, and we're looking at a binomial CDF. So that's B on the TI Inspire. The number of trials is 20. Probability of success is 0.5. The lower bound here is going to be 14, and the upper bound is going to be 20. And we press OK on that. And I'm getting an answer out for this one. So let's just get rid of this. So I'm getting an answer out for is greater than or equal to 14 is 0.0576 and so on. Now, that would not give me a 5% significance level. In fact, it could give me a 5.76% level, but 5%, that is too high. This percentage is too high. So we need to be within 5%. So 14 is not good. So then we'll check next, probability is greater than or equal to 15. So in fact, I could just do a control copy if I don't want to go through all my menus again of the binomial CDF and a control paste, so control V, and I can just change my 14 to 15, press enter on that one. And now I can see that I'm getting an answer here of 0.02069 and so on. Okay, so that's why they've got highlighted in green here 15 onwards and not 14 onwards. We need to find the first value where we're within 5%. So in fact, this test that we're performing here is actually a 2.069% significance level. But the statistician at the start determines the level of the test, the level of significance that we're looking for. So this is still a 5% significance level test. It's possible that the statistician could go back and say, oh, well, actually, we're looking for a 2.5% significance level to kind of game the test a bit. But the statistician normally sets out the parameters at the start, sets out what we're testing and what the significance level is. Okay, so let's take some of this back. So 15 is the first time when we're underneath 5%. Okay, so let's take some of this back as well. Let's get rid of that. Now you can see here, what do they say? Well, they say that R is equal to 15, and I've obviously just spent 2 minutes talking about that, but they've just come up with it. Okay, but you can do that through a trial and error on your calculator to find that X is greater than or equal to 15. Right, now there is another way of doing this, and I'm going to show you here as well. So on my calculator before, so when I was teaching this in class, I did this in reverse. So I did an inverse binomial distribution with 0.95%, 20 as n, and 0.95 or 95%, 20 as n, and the probability is 0.5. And I came up with the answer of 14 there. But you have to be really careful with the 14 because what that's really telling us when you do a binomial CDF, going from 0 to 14, is that we're trapping more than 95% in from 0 to 14. So we're looking for 15 onwards. I guess this is just a little bit more difficult to think about. So then I tried binomial CDF 20, 0.50 to 13, which actually wasn't necessary. And I found, there we go, that was the first time that I came underneath 5% there, came underneath 95% there. But yeah, that means that this, from 13 downwards, is, I don't know, 94% or something. This here is, what was that, something like 2%. And then we had a percentage in the middle for actually getting 14. Now, what we're interested in is getting the first time less than 5. I would really do this with trial and error. Okay, so I wouldn't use inverse binomial distribution, not unless you're super confident as to what you're doing. By the way, I would try and sketch down a little distribution to start off with to try and come up with a sense in my mind as to what's going on here as well. Okay, right, let's take some of that back. Okay, and let's bin this thing here as well. Okay, so that's 2. I'm going to take that one over to the side. So let's look at question 3 here. Let's get rid of this as well. Okay, let's take some of that back. Okay, so let's look at question 3. Question 3 says, state the lowest possible significance level of the test. Well, we talked about that. We could potentially come down to 2.06%, I think it was, which was the probability of being in 15 and upwards. Okay, but of course the statistician determines this at the start. Okay, let's have a look at the answers they come up with in the book for this one. So they come up with, there we go, the lowest significance level is 2.07%. Okay, right, there's been that little comment as well. Okay, so now we're on part 4 here. So part 4, they say, in a test, 18 out of 20 people preferred the new cheese. So we're really thinking that this new cheese is better now. But we just need to make sure that we're in the 5% region of the original distribution. And we still might be making a random error in that case. That's a type 1 error. It's called a type 1 error if you come up with the false conclusion that this cheese is better, when really it's not, and that we've just made a random error there. These people randomly chose the new cheese to be tastier. But we can see that 18 is within that 5% region. In fact, 18 is within a very small percent region. It's probably within a tiny amount. You know, maybe it's within a thousandth of a percent there, from 18 upwards. But it's certainly in our 5% region. Okay, so state the conclusion of this test. Well, any answer from 15, 16, 17, 18 upwards is going to mean that we accept H1, the alternative hypothesis, and we reject the null hypothesis. So again, let's have a look at that. For 5A, what are they saying? They're saying that we've got here, yeah, the probability of getting x is greater than or equal to 18 is 0.000201. Now, there's 2 ways of doing this. And again, this is actually really important, okay? So what we're finding here is this is the p-value for the test, the probability that x is greater than or equal to 18. You might consider, why on earth did we find the critical region when we just needed to work out the probability that x is greater than or equal to 18 and see if that's less than 5%? And you'd be right in thinking that, because this is completely valid. You do not need to go through the critical region test if you simply say, well, what's the probability that x is greater than or equal to 18? Okay, now that is called the p-value for this test. It's the probability of actually getting 18 or above if we're really, if the reality is that the null hypothesis, the original distribution, is true. So it's extremely unlikely that if the original or null hypothesis is true, that we are getting an answer of 18 or more people preferring this new cheese. Okay, and that is sufficient. That's the p-value. The p-value in this case is far less than 1% there. It's less than 1,000th of a percent, in fact. It's a 1/5 of a 1,000th of a percent. Okay, so it's tiny, so we can accept the alternative hypothesis. However, there's a second way of doing this question, and the second way says, how does this confirm your answer to question 3? Oh, which I think maybe I missed out, did I? State the lowest possible significance of the test. What are they saying here? Saying the probability is less than 0.05, and so 18 lies in the critical region. Yeah. So what they're trying to get us to talk about here is that we are the second way of dealing with these tests is to look whether or not we're in the critical region. So one way is to consider the p-value, the probability of being having x is greater than or 18. The other method is to consider, is 18 in the critical region? Okay, either of those means that we have a significant test and that H1 needs to be accepted. What do they say? Finding the p-value is often the easiest way for the significance test. Yeah, okay, right, fair enough. Okay, let's just see what it says on here as well. The null hypothesis is rejected if either test falls in the critical region. It is beyond the critical value, that is, or if the p-value is less than the significance level. Right, good. We are done with this. Okay, let's just see if there's an option to do this on the calculator as well. So let's go to menu, let's go to probability, let's go to distributions, and I'm not seeing any tests there. So let's go to statistics. So let's go to statistics, let's go to stats tests, and let's see if we have a stat test here. Nope, no stat tests to compare against the binomial distribution. Okay. Hi there, guys. So this is also done in the book via a calculator method. You can click through the calculator method. It's different to the way in which the book has done it themselves through talking through it, because the way in which they've done it here is to come up with a table of values based on, if you can see this one here, let's try and zoom into this. Okay. So they've come up with here a function on a table, and they've created the binomial CDF with 20, 0.5 as the probability, and then a CDF from x up to 20. And what they're trying to do is find the lowest value of x for which the probability goes underneath 5% for the critical value. Okay, so they've made this in a table. You can follow these instructions if you like. And there we go. They've put the function in here in the table. They've named this binomial CDF, and then they've listed 1 down to whatever. And they've found that 15 was the first place which went underneath 5%. To be honest, I would do that by trial and error. I think this is more difficult to do this on the calculator than just a little bit of trial and error on Scratchpad. So again, to go back to it, I think the better idea is to start off by sketching out roughly your distribution and thinking about where do I have 5% or less, and then just doing a few samples. You'll get there really quickly to find where the first value is 5% or less. Okay,